Okay, so let's. I may have to create maybe a different slide here to take notes. Um, we have 74.02%
Carbon,
carbon,
yes.
right? Or
Yes.
why don't you let me okay, hold on. You have the note. I'm going to create a new slide and you're going to tell me the numbers, Sylvia.
Okay.
Okay, what did the go ahead. The okay,
The
hold on. Let
the
me.
carbon, yes. Okay. The carbon were 74.02%,
Carbon is
or 2%.
74.02%. Okay, and what else?
Hydrogen was 8.71 gram,
Okay,
uh, and nitrate was 17.27.
okay,
I think the given molar mass was 162.3 gram mole.
okay.
Yes, yes, that's it.
That's it.
That's it. Yes.
Okay, so from this information, we are asked to determine the empirical
Empirical formula. Yes, molecular
formula
formula for
of
nicotine. Oh, was
nicotine,
it nicotine? Yes.
uh, and also the molecular formula, I believe, right?
Yes, sir.
And the molecular formula. Okay,
Formula. Mhm.
so the first thing that we need to do is that we we have to assume that we have 100 grams of sample. If you are considering that we have 100 grams of sample, for the sake of convenience, that will help us to convert the percentage value to grams. So carbon, hydrogen, and nitrogen, if you have 100 grams of sample, out of 100 grams, 74.02% is the same as 74.02 grams. For hydrogen, 8.71 grams, and for nitrogen, we have 17.27 grams. Okay, because we are working with the 100 grams of sample. So based on the percentage value, each of the elements would get equal amount of grams. That makes our job easier. So once we have this, the second step is that we need to find the atomic weight of each element, and we divide the grams by their respective atomic weight to get the mole ratio, to get their moles, their respective moles. So carbon, as you know, has I believe 12.01, and
Yes.
hydrogen has 1.008. Nitrogen has about 14, right?
Correct. Yes.
Good. Okay. So now we're going to see that if you divide 74.02 by 12.01, uh, okay, now we need to help each other here. I also have my cell phone with me. When we divide 74.02 by 12.01, what do you get by 12.01? I have, hello? What you have? I have 6.16. If you have a different number, let me know. Okay.
At 0.000616. All right.
Hmm? No.
I have a 0.20 and then a 616.
Yeah. If I divide, I have to divide. That's a mole for carbon. Is I have 6.16 one
Mm-hmm.
three 197335, but we can take with three
Around.
significant figure, Sylvia.
Okay.
We can go with three significant figure.
3.7. Oh,
Yeah,
okay.
so okay, go ahead and divide 8.71 divided by 1.008. Okay.
I have a question.
Yes.
Why are we doing this?
Who's
This
it?
is isn't this giving us the same number that we already divided by?
Say one more time, Anthony.
Isn't this giving us the same numbers we already have?
Yeah, this is a number that I created a new slide to make a calculation, and yeah, I don't know. This is the number that we have. We are trying to calculate the empirical formula for nicotine and accidentally the molecular formula of nicotine. They gave us what elements are in nicotine: carbon, hydrogen, and nitrogen with a percentage value. So we changed the percentage value to grams, and then we're trying to determine their mole ratio, right? And yeah,
Okay.
the numbers are the same. What is that a different number?
No, I'm just saying. I mean, I guess if this is what we have to do.
Yeah, this is from slide number 31. You can, Anthony, you can look from the.
No. Yeah, I get it. I understand that part. But it's just weird to me that we're dividing again by 12 and we're getting the same numbers we already had.
Yes, yes, yes.
Yeah.
We
I
need.
mean, okay. I mean, it's fine. Just ignore what I said.
Okay, okay. Let's go ahead. Okay, can we divide 70.27 by 14? Right.
Okay.
What's the number that we get?
1.23.
Which one?
1.23.
1.23. Good. Okay. This number, 6.16, 8.64, 1.23, these are mole ratios for carbon, hydrogen, and nitrogen, respectively. Now, what's the next step? What's the next step after this? We have to
So
find,
add. Mhm.
I'm sorry, what's the next step
After
would be?
we have to add. We have to add the number, all the
No, no, no,
numbers.
no, 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 Sylvia.
No.
We need to find which one is the smallest out of the three.
Oh, the smallest one.
The
Yes.
smallest, and
Okay.
then we divide by the smallest mole ratio. Okay, so obviously 1.23 is the smallest one, so we divide everything by the smallest one, okay,
Okay.
to get the mole ratio. So now 6.16 divided by 1.23, what do you get? This is a practice problem. I want everybody to participate here to understand very well how to calculate empirical formula and molecular formula if a percentage value or grams will be given. If it's not clear, of course, please ask me questions. But these are the steps, these are the procedure to do or to calculate the empirical and eventually molecular formula. So 6.16 divided by 1.23, 8.64, 1.23, 1.23 divided by 1.23. That's the reason the criteria is that we always have to pick the smallest mole ratio. So what's the number?
I
I
got
got 5.00.
5.08.
Okay, tell me for, okay, let me create another table here. Carbon, hydrogen, and nitrogen. If you divide 6.16 by 1.23, what's the number you get?
I got 5.01.
5.01, okay. 8.64 divided by 1.23,
7.02.
7.02, thank you. 1.23 divided by 1.23. I can do that, that's easy.
1.
1, yes. Okay, now 5.01, 7.02, and 1. 5.01 can be rounded to 5. 7.02 is like 7. This is 1. All right? Because it's very close to the integers. We don't need to find a number that we need to multiply to get another integers. So this means that 571 are the ratio of carbon, hydrogen, and nitrogen that would help us to write the empirical formula. These are the smallest whole number ratio. So it's going to be C5H7N. This is going to be the empirical formula. Okay, now we have another job. We need to determine the molecular formula. So the steps for molecular formula is we need to calculate first a factor that's called n, N is the ratio of the molecular weight divided by empirical weight. Okay. We don't know the molecular formula. However, we have given the molecular formula. I mean the molecular weight earlier. If you see here, 162.3. That the molar mass. The molar mass reflects the molecular weight. Okay, that's the molecular weight right there. So we have the molecular weight, which is 162.3, but we need to find the empirical weight. The empirical weight can be calculated from the empirical formula. We already determined the empirical formula a minute ago. So from here, I want you to calculate the empirical weight, okay? Which means that you have 5 atoms of carbon. You need to multiply 5 by 12 from the periodic table. The weight of 7 times the weight of hydrogen, 1 times the weight of nitrogen. So everybody is pretty much perfect in calculating the weight of the molecular weight or formula weight. As far as you have a periodic table, you multiply the weight of each atom by the subscript. So can you tell me what would be the empirical weight for C5H7 and N? If you don't have a periodic table right now in front of you, carbon is 12.01, hydrogen is 1.008, and nitrogen is about 14. So you can use this number. So you have to multiply 12.01 by 5, 7 by 1.008, and 1 by 14, and add them up together to get the empirical weight. 12.01 by 5 is, my calculator shows me 60.05. If you have a different number, let me know. 7 times 7 times that's the weight of hydrogen is 1.008, then that's going to be 7 times 1.008, which is 7.056. Okay, 1 times nitrogen, because the subscript is 1, that's going to be 14. So that's 1 times nitrogen, that's going to be 14. So we're going to add 60.05, okay, plus 7.05 plus 14. I have about 81.1, which is the empirical weight. So we have the molecular weight, which is 162.3, divided by the empirical weight, which is about 81.1. We divide the ratio of the two weights to get the factor n to determine the molecular formula, actually. So that is, if I divide 162, you can do that with me together. 162.3 divided by 81.1, I got 2.00. All right, so this number 2 is used as, is multiply the whole empirical formula to get the molecular formula. Okay, so the molecular formula equals to the empirical formula multiplied by the subscript n. Okay, that means n refers to the factor which we get here. N is this guy right here. So the empirical formula is C5H7n multiplied by 2, the whole thing by 2, that gives you C10H14 and N2. That's empirical. That's the molecular formula. Okay, so we got the empirical formula is here, and the molecular formula is here. All right. I have a similar question. If you have any question, you can ask me now, and then I'm going to give you a practice problem, the same problem that you can able to practice how to calculate empirical and molecular formula. But before we move to the next one, with the a question that I'm about to give you, if you have any question, you can ask me. But these are the steps how to calculate
I
molecular.
have a question, Professor.
Yeah,
I
yeah.
have first when we did like for carbon 74.029
Mhm.
divided by 12 point. Where's the 74 coming from?
It was given. It was given. It was
Oh, okay. So we take what's given and divide that by what's on the
by the weight of carbon. Yes.
okay, is that the atomic weight you said? What's the
Yes,
name?
the atomic weight. Yeah, the atomic.
Oh, okay.
All right.
Okay, thank you.
You're welcome. You're welcome. You're welcome. Any other question?
I had a question, Professor.
Yes.
Oh,
Tricia. Okay, go ahead.
yeah.
Okay.
I may have missed you. I'm sorry, my son came in the room. But
Mhm.
where you have the molecular formula equals empirical formula and then N,
Yes.
how do you know that the N was equal to 2? Oh, never mind. I got, because that's what we figured out, right?
Yes, that we have to
I
work
thought
out.
I see that now. Okay, I see that now. Never mind.
Okay, no problem. No problem. Okay. So based on this, I'm going to let you do a practical problem. I think I have seen one question here. Let me move on to the thing. Okay, well, let me do one more practical problem here. Maybe I'm trying to get if I get the equivalent, but here is a question. Here is another example, maybe. Penicillin contains 53.9% carbon, 4.8% hydrogen, 7.9% nitrogen, 9.0% sulfur, 6.5% sodium, and 17.9% oxygen. Okay, this is given. Okay, so this is a composition of each element in penicillin. From this mass percentage, the empirical formula and eventually the molecular formula of the compound can be determined. That's true. The only problem is that they didn't provide us the experimentally determined molecular weight. But if we can able to do the empirical formula, the race will be easier. I mean, it's not that much difficult. If we get the molecular weight, we can able to determine um, the n or the factor, but unfortunately they didn't give that to us. But let's see, this is already it's already a worked out problem. So what they did was um, they assumed that we have 100% sample, so every percentage value changed it into grams. So instead of 53.9%, they use 53.9 grams, just like what I did. They divide by the respective atomic weight. Okay, carbon has 12.01, and you get a mole ratio of 4.49. Hydrogen is 4.8 divided by 1.008, you get a mole ratio of 4.8. Nitrogen is 7.9, its atomic weight is 14.007, you get 0.56 mole. The same goes for sulfur, sodium, and oxygen. So all these, you get all the moles ratio here. Now, what's the next step? The next step is they they um, they pick the smallest one, the smallest mole ratio. Remember, you always have to start with the empirical formula first. So you get the smallest. The empirical formula by definition is the smallest whole number of atoms in a molecule. So you pick the smallest ratio, which is the smallest one is 0.28. It's right here. So every mole ratio divided by 0.28. You can look at it here. Carbon 4.49 by 0.28, you get 16. Hydrogen 17, nitrogen 2, sulfur 1, sodium 1, oxygen 4. So we got integers here. So all this number is used to write the empirical formula for penicillin. So the empirical formula will be C16H17N2N NaO4S. See, that's how the empirical formula determined. If we have been given the experimentally determined molecular weight, we can able to do the molecular formula, but they didn't give it to us. So here Here is the okay, here is something a little bit different. The steps for obtaining empirical formula from the combustion analysis. Determine the mass of the sample, burn the sample in oxygen, determine the mass of the combustion products, whether it is carbon dioxide, water, nitrogen, and sulfur, and you're going to determine the number of moles of each combustion product, and then use the atomic mass of the element to calculate the mass of the element other than oxygen in the original sample. And then find the mass of oxygen by finding the difference between the total mass of sample and the mass of all other elements. Use element percentage to calculate moles of carbon, hydrogen, nitrogen, and sulfur in 100 grams of sample. Divide the moles of each element by the moles of element present in the smallest amount and multiply by non-integral ratios as necessary to give small whole number. Okay, this is the steps to determine the empirical formula from the oxidation or combustion analysis. Let me, how about this one here? The strikers used to light Bunsen burners are made from a mix of iron, magnesium, and several rare earth metals. Okay, the substance in strikers is sometimes referred to as ferrocerium or fire steel. Okay, if ferrocerium is 42.55%, cerium 23.35%, lanthanum 21.35%, iron 4.25%, neodymium 4.25%, praseodymium, and 4.25% magnesium. What's the empirical formula? Okay, I'm going to give you this as a classwork and give you like a couple of minutes, maybe 7 minutes, 8 minutes, and then we have to come up with the formula. So this for everybody. Of course, you may have to get a predict table to determine the weight of each element here, and then we can determine the empirical formula, and we'll go from there. So this is going to be classwork. I'll give you like 5-7 minutes to solve this, and then we can discuss.
I have a question, Professor. Hello.
Yes, go ahead. Yes, I'm here.
Yes. What is the symbol for ferrocerium? I'm looking for that. I can't find it. Where is that? The first one, ferrocerium.
No, ferrocerium is the name of the compound of the striker. Ferrocerium or fire steel. Ferrocerium, ferrocerium doesn't have anything to do. The match striker is called fire steel, or it's a Latin word, ferrocerium. But
Okay.
that's not representing one element. So you need to find elements cerium and lanthanum. Most of these are active metals found in transition group.
Yes,
Iron, yeah, but don't worry with Sylvia with the ferrocerium. Ferrocerium is a technical name of the compound.
Okay.
Yeah.
Okay. All right. Thank you.
Professor, I have a question.
Yeah. Yes. Go ahead.
So after you divide by the molecular mass, the mass of the molecule, what happens then? What's the next step?
That's a good question. I looked at it, but they didn't give us. So we don't have to do the molecular formula here. We just have to determine the empirical formula.
Oh, okay.
Yeah, we don't have it. I was thinking about that too, same way, but I checked that it's not here. Anthony,
what is the rule for the rounding? Let's say I have a number 10.29.
that can be.
Does it become 10?
That become 10. Yeah, that's 10 points.
Okay, and what about 5.7? Does that become 6?
No, that has to be multiple. That has to be that's. Did you get that number?
Yeah.
Okay, that's not a good number. That has to be multiplied. You remember we did some practice the other day in
Yeah,
one
yeah, where we
that is
multiply to get like the
so
nearest whole number.
5.7 is not a number that you have to round it up. So in that case, the 5.3 is also so we have to multiply 5.7 as well. I mean the 5.3, what was the first number that you get?
10.29.
Yeah, that has to be multiplied. Okay, I think this is a little bit crazy number. So we do okay. I'm going to use a new slide. So can somebody dictate me to write what's given here?
Yeah, yeah, you got it. You can go ahead.
Okay. Okay, so we can do this together, I guess. So let's see.
Yes.
Okay. Tell me each element, and then I can able to write here.
There's 42.55% of cerium.
Okay.
There's 23.35 of lanthanum.
Okay.
21.35 of iron.
Okay.
4.25 of neodymium.
Okay. I think
Neodymium.
Okay.
4.25 of, dang it, what was this? Oh damn, I forgot that one. Magnesium,
Magnesium, yes.
Okay.
and then 4.25 of something else, but I forgot it.
It's a praseodymium.
Oh yeah.
Praseodymium. Yes.
Okay.
Presidium, yeah, something like
Presidium,
that.
yes.
Okay.
Yeah.
Okay. Wonderful.
PA. Oh no. PR. Yes, it's a PR.
Okay. So we
Yes.
take, to make it easier, we take the sample as if 100 grams of the sample, so that all the percentage value changes into grams. So we have 42.55% of selenium. So what is the atomic weight of selenium? I don't have a periodic table here with me.
It's
It's 140.12.
One,
140.12.
140.12.
Correct.
Yeah.
Okay, 23.35 lanthanum. What's
It's
this? It was
one
okay.
three 138.91.
Okay, okay.
Okay,
21.35 iron. What's the weight of iron? 55.56.
55845.
No. 845.
55845.
845. Okay, okay,
Yes.
okay. 4.25. The weight of neodymium, Nd.
14424.
What?
14424.
Yeah, 144.24.
Correct.
Okay, and
I
then
have a different number.
okay.
Which one did you get? It's the one
We're
for
doing. We're doing. Wait. What are we doing?
it's a P, the
And
neodymium.
Presidium or per? Yeah. I got
Neodymium, yes.
140.91 on my periodic table.
That's a PR. That's a P. That's a praseodymium. It's the one with the 140.91.
Now what are we doing now?
The one we talked. The one is next to it. The ND.
next to iron.
Close to PR.
Okay. What was the number again?
144.24.
Oh yeah. My bad. I'm sorry.
No problem. 144.24. Okay. And
Yes.
then we have the same percentage for magnesium, the same percentage for palladium, right? So
Yeah.
we have 4.25 magnesium, I believe something like 24.04 or something.
24.304. I mean 305. 24.305. That's magnesium.
Okay.
And then what else is there?
24 point what?
305.
304. 305.
Okay.
Yes.
So the last one for palladium.
It's 140.91.
Which one is that, Anthony? Which one?
The PR.
The PR?
Yeah. Oh,
Is that 140.91?
that's right.
Or is it 130?
Yeah, that's right.
140.91.
Yeah,
140 point what?
91.
91.
Okay, all right. So now let's start the division here. 42.20. We have to find the more ratio here. Okay, 42.55 by 140.12 with the first one. Selenium. What do you get?
I got 303.
Okay, 3.03. Okay, 23. 23.35 of lanthanum.
1.681.
1.681. Okay.
Yeah.
21.35 iron. That is
Point. Wait. Actually, I got the decimal over to the left one.
okay.
For the first one, I got 0.3037. And then for
Okay, let
this,
me. Okay, hold on. Let me. Yeah, it should be. Okay.
yeah, it shouldn't be a whole number, right?
Yeah. No, we first have to get the more ratio, and then we divide by the smallest one, and that's where we
Yeah.
determine. Okay, so we still have works to do. We have to just divide to get the more, and then we will get the more ratio by dividing with the smallest whole number ratio. So okay, for the first one, go ahead, Anthony.
0.3037.
0.3037. Okay, the second one.
0.1681.
For the third one.
0.3823.
Okay, for the fourth one.
0.0295.
For the next one, I think
0.0302.
0.0302. Okay. For the next one.
You forgot the 0 in front of the 3.
Okay.
It's 0.1749.
0.1749. Okay.
Right.
That's all?
Yeah.
Okay.
How
Okay.
did you, sorry, Professor Anthony, for the last one, what did you round? Because I did get 0.1748. Did you?
Yeah,
Yeah, you
that
had to
was
round
the
that.
same.
You had to round that last number.
Yeah,
the
that's
last number too?
0.1749.
Then it become a 0.1775. So we need a 4 number?
No, I think we can. You can do that, and if you keep to 4 decimal, I think most of the numbers that you have is four
Four
significant figures. So I don't see
Oh,
why
okay.
we need to round it up.
But to round that here.
Yeah,
So it's a
I don't see the reason why we need
0.1748. Yeah.
1748 or 1749.
I got 1748
What's the number next to that? Next to the calculator display
at the
showed you.
at the 6. At the 6. So you have to
So that
round
can
it?
be rounded, Sylvia. If it is 6,
Oh, okay,
then
then
it
it
can be
would put a
rounded
9.
to 9. Yeah.
Yes, then it become 9. Yes. Mhm.
Okay, now the next step is going to be we have to pick the smallest more ratio from here. Okay, the smallest one to me is, what do you think? The smallest one is the ones that's 0.0295, right?
Correct.
So we have to divide everything by that. Okay. Okay. So to follow up, okay, the step here, we got 0.3037. What was the element that we get here, so that I can write from at the top so that we will not make a mistake?
For which one, sorry?
For the first one, let me clear up a little bit here. Now above each mole ratio, we have to write the name of the element, Anthony, okay? I don't have a
Okay.
predicate table, so you need to tell me where do we get that 0.3037? That comes from 42.55,
Yeah,
right?
that's Syrian. Yeah, that's Syrian.
Syrian,
That's CE, right?
CE,
Yeah,
correct, yeah.
Okay. And 0.1681, where does that come from?
LA.
LA. 0.3823 comes from
FE.
FE. 0.0295 comes from
ND.
And mhm.
0.0302.
PR,
PR.
Okay. 0.1749
MG.
and
mg. Okay, wonderful, thank you. Okay, so let's do the ratio now. 0.307 divided by 0.0295, what do you get?
10.29.
0.1681 divided by 0.0295.
5.7.
0.3823 divided by 0.0295.
12.96.
it cannot be, oh, you did round that, okay, yeah.
This can be rounded to
12.9.
13 to me. This one is easier, I can do that one.
No, because it did round the fourth number, because the answer was at 12.959,
Okay,
and it did round that to 6.
that can be rounded 12.96. That's fine, but
It can be rounded too, then it
yeah,
become 13.
it can be 13. Yeah, pretty much would be
Okay.
13. Yes, this can be 13 because the rule is that if it is like 12.9 or anything above 9, that can be rounded, but something like 5.7 or something like 10.3 has to be multiplied.
Okay.
0.0302 divided by 0.0295 for PR.
It's a 1.024.
Okay, 0.1749 divided by 0.0295, the last one for magnesium.
5.929. So 6.
5 points, what?
929.
Okay, this is like 10. This is like 6. This is like 13. This is like 1. This is like 1. This is like 6. We have to do it this way. So the formula would be CE. It's a little bit complex problem actually.
Yes, it
CE
is.
10, LA 6, FE 13, PR 1, and MG 6. That's what if you ask me the name, I don't know the name. That's why they said ferricium. Ferricium is the name of this compound here, which is the iron steel. It's a match striker. You know the match striker. When you do the lab, when you do the lab in chemistry lab, instead of using a match striker, you cannot use a match striker. You use you use match iron with iron to create fire. That's this compound right here. Let me see if I can able to pick one here from my instructor manuals. The goal is how we can able to determine empirical and molecular formula from the given percentage. So